Hello and welcome to another tutorial of Proflan YouTube channel. In this particular video, we're going to go through all the integration techniques you need for your P3 paper. Before you go to do your exam, make sure you know how to perform this kind of integration. We have a set of 10 questions that is going to take you through on all the integration techniques that you are supposed to learn in order to perform P3 examination for CIE A-level math. Now we need to go straight to the first one, and we are told that integrate cos cubed x dx. Here we are going to use u substitution. So this is what we have. This is what we have at this given point. We are given question number 1, integrate cos cubed x dx. Remember, on this question here, we cannot be able to say that cos u equals to cos x, so that we can be able to perform u substitution here. But we are going to write this. We can be able to express this as integral of cos squared x cos x dx, right? So that we are going to say our u is going to be sine x. So once you have u like that, we can be able to substitute here, but we are going to find now du. Our du is going to be cos x dx, right? So once we have this, we know that anywhere we have cos x dx, we are going to replace that with du, right? So which will mean that our expression here is going to be integral of cos x. So this can be written as u So this is going to be written as, because we are going to express this again, we're going to say integral of cos squared x cos x dx. So this part that we have here, we are going to write it in terms of sine squared. So we're going to say this is going to be written as 1 minus sine squared x cos x dx. So next, now we are going to substitute. Anywhere we have sine, we are going to substitute u. Anywhere we have du, anywhere we have cos x dx, we are going to substitute with du here. So this is going to be, integral of 1 minus u squared du. So at this given point, we can be able to integrate term by term, and this is actually going to be u minus u squared plus 1 over 2 plus 1. Then we are going to say plus c. Now, once you have gotten your integral, simplifying to u cubed over 3 plus c, then we are going to replace now the u that we had said. So this is going to be sine x, because our u was actually sine x, and this is going to be minus 1 over 3 sine cubed x, then plus c. Now this becomes the answer in that kind of situation. So let's check number 2. What are we having? Which other techniques do you need in order to do your P3 paper? I'm having integral of 9 over. We're going to have question number 2, integral of 9 over 4x squared plus 1. So in the event you are given this kind of question, you need now to ensure that you are going to take this 9 out, so that we are going to have integral of 1 over, and I'm going to factor this 4 out also, so that I'm going to remain with x squared plus 1 over 4 in that case, then with respect to x, right? So this 4, I can be able to bring it out, so that I'll have 9 over 4, right? Integral of 1 over x squared plus 1 over 2 squared with respect to x. You need to remember this kind of question that you learned. So remember, you had learned that if you are integrating integral of 1 over x squared plus a squared with respect to x, when you're integrating that, you said that this is going to be 1 over a tan inverse over x over a, like that, then plus c. And that is actually the technique that we're looking at this in this case. So this one is going to be 9 over 4, and then we're going to multiply by 1 over a, but our a is a half. 1 over a half is going to be 2 tan inverse of x over this is going to be 1 over 2 here plus c. And finally, this is going to reduce to 9 over 2 tan inverse of 2x plus c. And that is exactly what you are supposed to do. So in the event you have an integration that looks like this is the procedure you are going to follow in order to perform that kind of equation. Let's look at number 3. Which techniques do you need in order to work out question number 3? You are supposed to learn how to integrate exponents. Exponents are a question that also they are very, very, very important for you to know how to integrate. So number 3, integration of exponential functions. Now, integration of exponential functions. Suppose you are given a question like this. How are you supposed to integrate that kind of equation? You are told integrate e is to 3x plus 4 dx, and then you have your 5 at this. What are you supposed to do in order to integrate this? Now, integrating exponential function, this is what we're going to do. If you are having this kind of a scenario, we're going to factor the 5 out so that we say we are integrating 3x plus 4 with respect to x. So which will mean that if you integrate this, you are going to get 5 over the differential of this, differentiating the top. What are you going to get? You are going to get 3. So you are going to say 5 over 3, a is to 3x plus 4. That is exactly what you do in order to work out this question. So meaning that if it's combined with other kind of expressions, if you are having e is to 1 over 4x minus 3 plus ln over x, yeah, you are integrating this with respect to x. What does it mean? You are going to integrate term by term, of course, this part, and this is going to be differentiating the top. You are going to get 1 over 4, and 1 over 4, 1 over 1 over 4, e is to 1 over 4x minus 3, then plus. Integrating this, we are going to get the answer what? So in the event you are given another one that is having maybe 3 is to 1 over 4x minus 5 with respect to x, when you're integrating exponentials, we are going to say that we are going to take 3, of course, out over if you differentiate this part here, you are going to get 1 over 4. So this will be 1 over 4 here. Then e is to 1 over 4x minus 5 then plus c at that given point. So meaning that this is going to translate to 12 e is to 1 over 4 x minus 5 then plus c as the integral. So you need to know how to integrate exponential functions. We need to move to integration of polynomial. We need to go and now look at how do you integrate trigonometric functions. How do you integrate trigonometric functions? So you can be able to use U substitution in trigonometric functions, but however, I need to bring to your attention that if you are given a question like so if you are integrating a trigonometric function like sine 4x dx, integrating sine 4x dx. Now, how do you perform this? Remember, if you integrate sine x is negative cos x. But if you are having a number here, a variable here, 4x, you are going to say 1 over 4. Because if you differentiate this, you are going to get 4. So you are going to say 1 over 4 of this. You are getting it from this point. And then you now integrate the sign itself. So this is going to be negative cos 4x then plus c. So finally, we're going to have negative 1 over 4 cos 4x then plus c. Because of that, ensure that when you are having a function here on this trigonometric function, you are going to differentiate it, divide it like that. In the event you are given tan squared 5x, powers of trigonometric functions, powers in trig functions. Powers in trig functions, you are going to approach it in two ways. You can be able to use Pythagoras identities, or you can be able to use double angle. For instance, if you are given integral of cos, so remember that cos 2a is equals to 2 cos squared a minus 1. So meaning we need to reduce this power so that we have it as double angle. So meaning that we can be able to express this, our trigonometric function here, in double angle. So we are going to write here as 2 cos squared a, but our a is here, which is going to be 3x minus 1. Then on this other side, we're going to have cos of 2 times a. Our a was that, so this becomes 6x like that. So meaning that if we are having this expression here, we can be able to rearrange it and say this is going to be cos squared 3x is the same as cos 6x plus 1 then over 2 like that. So meaning this expression that we have here can be able to be replaced with this. So once you have done that, we can be able to say now our integral of that is going to be 1 over 2 cos 6x plus 1 over 2 with respect to x. Then we're going to integrate term by term, and we can factor this half out. So we are going to say 1 over 2, right? Cos 6x dx integral of 1 over 2 with respect to x. Now, if we integrate this, we are going to say you are going to differentiate this function you have here, which will mean that this is going to be 6. And then our answer is going to be 1 over 2 over 6, right? Integrating cos is actually sine 6x, then plus 1 over 2x plus c like that. Integrating this, we're going to get 1 over 2x, then plus c like that. So which means that if we simplify this, we are going to get our answer being equal to 1 over 12 sine 6x plus 1 over 2x plus c. So anytime you have powers on sine, you have cosine powers on cosine, sine and cosine. You need to use double angle in order to reduce it like that, so that you can be able to perform the integration. Still in trigonometric functions, you may be in a scenario whereby you need to perform to perform this, you are going to sort the help of Pythagoras identities. So remember, 1 plus tan squared A is equals to sec squared A. So which means that we can be able to express this tan to sec, because in our MF19 we have how we cannot be able to, we don't have the technique to integrate tan squared, but we can be able to integrate sec squared. So which will mean that this one we can now say 1 plus tan squared 3x is equals to sec squared 3x, because our A is actually this particular part. So meaning this term can be written as sec squared 3x minus 1 with respect to x, like that. So which will mean if we are working out this thing, is going to be integrating this, we are going to get tan, integrating this, remember we have this 3x here, so we're going to say differentiating this, we're going to get 1 over 3. But integrating sec squared, we are going to get tan. So we are going to get a third tan 3x, then minus x plus c, like that. So we are just looking at how to integrate. Of course, if you're having the limits, you can be able to put them in so that you can be able to proceed. Another integration technique you need is whereby you have a function like this. If you are told to integrate a function that is like this, you are having 8 over square root of 5x minus 5 with respect to x. How can you be able to integrate such kind of equation? So this one, you are going to say this can be rearranged, and it can be rearranged as into bracket 5x minus 5 raised to power negative a half, like that. So to integrate this, we are going to say, we shall write it the way it is, 5x minus 5 negative 1 over 2 over, then we're going to say plus 1, then that plus 1 we're going to say here minus 1 over 2 plus 1 down here, then times the value that you have here times 5, right? So which means this is going to translate to, if you are having this, you are going to have a half times this is going to be 8 over 2.5 into bracket 5x minus 5, 1 over 2. Of course, this is going to translate to what? Let us just our calculator. Actually 8 divided by is going to be 16. This is going to be 16 over 5. 16 over 5. 5x minus 5 square root. So then we're going to say plus c at that given point. So given such kind of equation, be sure that you can be able to perform it. We are going to move to which number? We are moving to number 6. integration by parts. Integration by parts question. Now, integration by parts is going to involve those questions that have two functions multiplied together. And for instance, if you have a question which involves this kind of integration by parts, by parts, right? So by parts, you are given a question like e to x raised e to x sine x with respect to x. Then the first thing that you need to know is what is going to be your u and what's going to be your v. So we're going to use what we call Lipet. We're going to apply Lipet there, and this is Lipet enables you choose the value of u, and the other part that if you have chosen one to be u, the remaining one is going to be dv. So this is going to be what? If you are integrating u dv, and this is going to be uv minus integral of v du. So this is integration by parts that we are going to perform. So according to Lipet, if a natural log is in this expression, is going to be your u. If it's not there, you check, do you have inverse trigonometric functions? If they are there, you take them as u. If you don't have trig, you check, do you have a polynomial? If a polynomial is there, it's going to be your u. If it's not there, you move to exponent. If the exponent there becomes your u. And if you have trig, you need to check that. So according to this, we have exponent and we have sine, which is a trigonometric function. So we are going to pick e exponent as our u. The other one is going to be our dv. So meaning that in order to integrate this, e is to x sine x dx like this, we are going to say we shall have, let me just draw a table that can enable us do this. We are going to have a table, and our table here is going to have u, and another one is going to have du here, and we shall have dv at this point, and this is going to be our v at this point. So which means that we are going to say, we have said that our u now, in this case, our u is this, is going to be e is to x, like that. And our dv is going to be sine x, like that. So in order to get du at this given point, we are going to differentiate this exponent and we are going to get exponent, because if you differentiate an exponent like that, you are going to get the same answer. But if you are going to find v, you are going to integrate this part. Integrating sine x, you are going to get negative cos x, like that. Then once you have done that, you are going to multiply across so that you have your u times v. If you are multiplying like this, you take that as positive. So this is going to be a x times negative cos x. Then you are going now to multiply diagonally like this. And when you are multiplying diagonally, you are going to take that as a negative. So that's why we are having this negative here. And this is going to be integral. Then you write our v is negative cos x, then e is to x, then dx at that given point, right? So meaning that this is going to reduce to negative e to x cos x minus integral of, now this will be positive, because if we take this negative out, it's going to be positive, and then we have cos x e is to x with respect to x. So meaning that again, we have two functions here which we need to integrate for the second time. So we are going to again decide which is going to be our u, and we work du, which is going to be our dv. we work our value of v. So let's see what we are going to do at that given point. Now, if you look at this, because we are having cos and we are having x, so again we have exponent and we have trig. So meaning that exponent will be our u. So we are going to say this is going to be our u is to x. And again, if we differentiate this, we're going to get e is to x. Our dv is going to be cos x. And you see, if we integrate this to get v, we're going to get sine x at that given point, right? So meaning that if we multiply across, we are going to get e sine x, right? E sine x. So this is going to be minus e is to x cos x plus. Now, integrating this part is going to give us what? Let's see. Is going to give us e to x sine x, right? Right? And we are going to have minus the product of this, we are going to get e to x sine x, right? But now we are going now to do what? We are going to integrate that with respect to x. But if you look this part that we're having, this thing is going to continue and continue forever. Then this one we are having where we are started. We are having something that we are started with. So at that given point, we are going to say, now this integral can be written as, let me just write it here. This integral can be written as integral that the one that we started with was a is to x sine x with respect to x is equals to this part negative e is to x cos x, right? Plus a is to x sine x then minus integral of e is to x sine x dx. So you see, this part is the same part that we are having at this given point. Yeah, this given point here. So meaning that we can now take this part on the other side of the equal sign. It's a minus. We take it on the other side. We are going to add it with this. So that we are going to say now this is integral of e to x sine x with respect to x plus, right? Integral of e to x sine x dx is equals to, now we start writing these ones here, minus e to x cos x plus plus e to x sine x. Now this is actually going to reduce to 2, so we shall have 2 integral of e to x sine x dx is equals to minus 1 minus e to x cos x plus ex sine x. Then now divide by 2 all through to here. So we are going to say plus e to x sine x, a half of this, then plus c at that given point. So this is what is going to reduce to. So those are some of the integration techniques that you need. And those that are going to continue like that and continue forever, you're going to leave them at that given point. All right, we are almost done. We are almost done on what we're expected to do. And we are going to look at, if you are given question number 8. Number 8, you are told if you are supposed to integrate sine squared 5x with respect to x, what are you supposed to do in that kind of a scenario? We have done a question that is related to this, and of course, this one we need to sort double angle. We need to sort double angle concept, and that is to say, if you're having this, but you need to remember that cos 2x is equal to 1 minus 2 sine squared x. 1 minus 2 sine squared x, or let me just use a so that you can be able to see that in a big picture. That's going to be 2a is equals to a here, but our a in this case is going to be 5x. So that will mean that if we bring this sine squared here, we're going to say 2 sine squared, our a is 5x, 1 minus that is equals to, this is going to be cos 2a, so 2 times 5, so that's going to be 10x, right, like that. And now we can be able to make sine squared the subject. If we rearrange this, what are we going to get? You can say therefore sine squared 5x is the same as 1 minus cos 10x, right? Then divide by 2 all through over 2, like that. So meaning if you have this integral here with respect to x, then you are integrating, it's like integrating this, so which will mean that this is going to reduce to integral, let me just write it, integral of 1 over 2 with respect to x minus integral of 1 over 2. I can take this 1 over 2 out. I'll take this 1 over 2 out so that we have cos 10x with respect to x. Now to integrate this, of course, this is going to be 1 over 2 x minus 1 over 2, this 1 over 2 times 1 over 10 sine 10x, then plus c. And this is going to translate to 1 over 2x minus 1 over 20 sine 10x, then plus c, like that. So if you have the limits, you know exactly what you are supposed to do. But the purpose of this video was to take you through all the integration techniques that you need for your P3. Then at the rest, you're going to know how to go about it. Now, question number 9, I'm going to take you through one whereby you are supposed to work out, of course, you are supposed to work out x squared sine x with respect to x. Of course, this question here, you can be able to use integration by parts. You can decide this using Lipet, you can be able to assign this u and this to be dv, then perform this by integration by parts. But now I need to take you through how can you be able to take less than 1 minute in order to do that, because integration by parts, you are going to perform integration by parts twice in this question. Now I need to show you how to use tabular method. Now under tabular method, we are going to draw a table like this, and we are going to have the derivative, and we are going to say what you are going to integrate. So the derivative is going to be the polynomial, yeah, one you can easily differentiate until it diminishes. But this one you say integrating differentiating sign, it keeps on oscillating from sine and cos, sine and cos, sine and cos. So this d is going to be x squared, and this is going to be our sine x at that given point. So we are going to differentiate this. We are going to get 2x. Again, we differentiate that. We are going to get 2. Again, we differentiate these 2. We are going to get 0 at that given point. We integrate this. We are going to get negative cos x. We integrate this. We are going to get negative sine x. We integrate this. We are going to get positive cos x, because integrate, if you integrate sine x, you're going to get negative cos. So, and there's this negative, so this is going to be positive. Now, once you are done this multiplication, you are going to write this plus, minus, plus, minus. So you start with positive, negative, like that. So there's no negotiation on that. You have to start with positive, negative, like that. And then now you multiply this to this to this, you add it to this to this. So meaning you are going to have integral over this expression that you are having, x squared sine x with respect to x, like that. So which will mean that this is going to be x squared sine x, like that. This part times this part is going to be negative x squared cos x, right? This times this is going to be a positive. So we're going to say plus 2x sine x. This times this is going also to be a positive value. So this is going to be plus 2 cos x, like that. And then we shall now say plus the constant that we are talking about at this given point, plus this constant. So you can be able to perform such kind of equation. So maybe we can be able to use this method so that we can be able to check in the event you have this kind of question to perform. You are told to integrate x squared cos let me see what have I written here, cos 2x with respect to x. How can you be able to use this method in order to perform this? So we say the first thing, just say this is d and this is I. So our d is going to be x squared, our cos is going to be our I cos 2x, like that. So instead of using integration by parts, we can be able to apply this method. So we are going to differentiate this. This is going to be differentiating this. We are going to get x 2x, like that. Again, differentiating this, we are going to get 2. Again, differentiating this, we are going to get 0 at that point. Now, our d is going to be x squared our d is going to be x squared here. X squared going to be our d, and this part is going to be our I. So this is a cos 2x. Now differentiating this term, we're going to have 2x. Differentiating 2x, we're going to have differentiating 2x, we're going to have differentiating x, we're going to get 2 at this point. Differentiating a constant, you are going to get 0 there. Now integrating this, we are going to get 1 over 2 sine 2x. Integrating this, we are going to get 1 over 4 cos 2x negative. Because if you integrate this, you are going to have another 1 over 2 on this side, which is going to be multiplied to this 1 over 2, you get negative 1 over 4, because integrating sine, you get negative cos. Now, again, integrating this, we are going to get negative 1 over 8 sine 2x at that given point. Now, you see, since we have 0 here, we stop at that given point. So, which sign are we going to say here? We are going to say positive, negative, positive, negative. So, therefore, we are going now to multiply. You are going to multiply this to this guy, this to this guy, this to this guy, and then you add them all together. So, meaning that integral of x squared cos 2x with respect to x is going to translate to what? This times this is going to be a half x squared sine 2x. This time this is going to be, of course, this is a negative at this given point. This is a negative here. You have to remember that. So meaning negative times a negative will be a positive. So we are going to say plus what? Plus this is going to cancel. So we are going to have 1 over 2 x cos 2x at that given point, right? So of course we are done with this part. Let me just do away with this so that it doesn't give us obstructions. Yeah, so we are done with this. So this time this is going to give us, of course, this is going to be a negative here. There was a negative at this point times this positive, so it's going to be minus 1 over 4 sine 2x. Then we can now say, if we didn't have the limits, of course, you cannot be given a question that doesn't have the limits. You are going to leave it at that given point. All right. Now, also now, don't forget to work out question to do with integration by partial fractions. Don't forget that. Integration using partial fractions. Don't forget this. As you are preparing, don't forget this. Remember, when you can be given a question like integrate. Let me just give an example. Integrate x minus 4 over, and then this is actually x squared minus 6x plus 5 with respect to x. And you can see now the part that we are having here is actually a quadratic. So which will mean that you can be able to factorize this quadratic, and then you are going to have x minus 4 over, if you you factorize this denominator, you are going to have x minus 5 into x minus 1. So with respect to x. Now we can be able to express this as partial fraction. So since we are having linear part here, we can say this, we can now look at now this part, we can look at this expression and say this is actually x minus 4 over x minus 5 into x minus 1. Of course, in partial fractions, this can be written as a over x minus 5 then plus b over x minus 1. So you try to work out these constants. Of course, when we were learning about expressing in partial fraction, we're going to multiply all through by x minus 5, x plus x minus 1, yeah, so that this part will cancel out. Here we're going to multiply all through by x minus 5, x minus 1, and here we are going to have x minus 5, x minus 1, like that. Of course, this will cancel here, and then it will mean that this expression that we have is going to be x minus 4 is equals to a into x minus 1, then plus b into x minus 5, like that. So we can now say we need to find the constants here. So we can say when x is equals to 1, when we can replace x is equals to 1 throughout this expression we are going to have minus 3 is equals to a times 0 plus b into 1 minus 5 is going to be negative 4 at that given point. So which implies that in our this equation we are going to have minus 3 equals to minus 4b, which means that our b is actually 3 over 4 in that case. So we have gotten the constant b, right? Then the next one, we are going to say when x is equals to what? Is equals to 5. This expression that we are having here, what is it going to be equivalent to? So we are going to substitute 5 into this. We are going to say 5 minus 4 is going to be actually equal to 1. Then a into 5 minus 1 is going to be actually 4. Then plus b into 0, right? Because 5 minus 5 is 0. And this is going to leave us saying that 1 is equals to 4a, which implies that our a is equivalent to 1 over 4, like that. So that will mean that this expression that we are having here, or we are having at this given point, can be expressed in partial fractions, right? So which will mean that our partial fraction, therefore, remember our partial fractions are a over x minus 5. So this implies that a over a over x minus 5, x minus 5 plus b over x minus 1 can be written as our a is 1 over 4 over x minus 5 plus 3 over 4 over x minus 1, like that, right? So which means that this is the part that we are integrating. So this integration that we were having at this top point here is going to reduce to the part of that we have expressed in partial fraction, and the part that we are talking about is this part here. So meaning that we are integrating 1 over 4 over x minus 5 plus 3 over 4 over 1 minus x minus 1, like that, with respect to x. So we are going to integrate term by term, and of course you need to remember, if you are integrating this, you are going to take 1 over 4 out, integrate 1 over x minus 5 with respect to x, then plus integrating 3 over 4 out, you will have 1 x minus 1, like that, with respect to x there. So which means that this is going to be 1 over 4 ln of x minus 5 plus 3 over 4 ln of x minus 1, like that, then plus c. So basically, that's what you are supposed to do in that kind of a scenario. However, in the event you are trying to integrate an expression and you realize that maybe it's 2 over 3x minus 5 with respect to x. You see, this one we have just taken the denominator and we have put it in ln. But since if you are having a term in front of this, if you integrate this, this is going to become 1 over this number. So that's going to be 3 over 2, the reciprocal of this, then ln of 2 over 3, 2 over 3 x minus 5, like that, then plus c. So these are the most important integration techniques that you are expected to learn in order for you to comfortably perform in a P3 paper. So make sure all these integration techniques that we have gone through here, you have at least them at your fingertips.